Hello guys, welcome back to another video. So two with videos within space of 1 week, that's crazy, isn't it? This is a bit of a different video because we're going to be doing a bit of cleanup and we're going to implement some unit tests. So probably a bit more of a boring video. If you want to skip this one, fair enough. But we're going to show you, basically we're going to tidy up our code. It's a bit of a mess at the moment. And then we're going to write some tests and set up some CI on GitHub so we can make sure we're not breaking everything when we make some changes. So let's make a new branch. We'll call this episode 4. Call it unit tests. And let's start off with some tidy up. So our entry point at the moment is in main, that's fine. We could probably get rid of this note at the top, to be fair. So this is basically where the compilation happens, and what I wanted to do was I wanted to basically put it into its own API, and we call it compiler. So when we initialize a compiler object, we're basically not going to pass in anything, but we have this sort of debugging here. So we want to be able to basically log tokens, and then we also want to be able to log the abstract syntax tree. So we're going to initialize two. What did I just type there, man? So we're going to initialize two things, two variables, and you'll sort of see what we do with those in a minute. So this is going to have a public method called compile, and the main reason we're making this compiler API is because when we do our unit tests and we want to do like a full end-to-end test, doing this is quite nice because we can just import this. It tidies up this bit down here and basically just makes it a bit more reusable. So what we're going to do, we're going to take all of this and we're just going to chuck this in compile. And I've just updated my VS Code so that it formats on save now using, I think it's prettier. So it should make our code look a little bit nicer. So let's just write what we're doing here. So first, tokenize input. This should also take input as a parameter. We'll get rid of this, don't need that right now. And then next, create AST. Okay, get rid of that as well. Finally, evaluate result. Now what we've got is this tokens here, but we actually want this to be accessible from the class itself. So we want to do this.tokens equals lexa.tokenize this.ast, and then when we pass, we're going to need to pass in this.tokens and this.ast as well. Cool. So we'll get rid of the console log and we'll just return whatever evaluated.evaluate gives us. So I think that's fine. Now in our main function here, we've got this add more commands. Let's add a couple more commands. So if input equals, let's do AST. We'll make a new variable here called show AST. So basically we're doing exactly what we're doing here, but we're using AST instead, which will print the abstract syntax tree to the to standard out. So let's change that. Cool. I think that's fine. There's one other little thing I want to add here. If we have an empty input, so if we just do like that, then we just want to continue, because if we didn't have that in there, then it would like say invalid token, but we just wanted to put a new line on there. So that's cool. So we can add more commands later down the line if we need it. So now what we're going to do is I've got some other refactoring things I want to do. So if I open this to the right, So whenever, I'm just going to format this as well. Whenever we have an error within our lexer or parser, we're just sort of returning and we're just logging it. I want to create some custom errors so that we can better handle. Well, basically, if we create some custom errors, we can just basically wrap our compilation API just into a try catch, and then we can handle errors depending on what kind of errors they are. So let's get that going. Let's make a new file called errors.js. Now, let's make a abstract error here. Just call it compile error. It extends from the built-in JavaScript error. And when we initialize one of these, we just basically pass in a string. We'll just call that message. And we want to inherit all of the properties from error, so we're just going to pass in message as well. And then we'll just give it a name. Just call it compiler error. I think that's fine. Cool. Now we can create our lexer error, and we'll just extend compiler error. So the reason we're doing this is, I'll show you in a minute. Actually, it will make sense. We can basically just copy this. The name is going to be a bit different though. It's just going to be lexer error. And then with these errors, so we're going to have a lexer error, we're going to have a parser error as well, and maybe an evaluator error class. When we do a try catch, it's going to print a whole load of it's basically going to print the whole call stack. So to get around this, we'll define a method called toString, and basically we're just going to return this.message. So if we were to throw a new lexer error, it'd print out the whole call stack, and then it'd print our message at the very top. However, if we catch the error and then do console.log error.toString, we can basically omit the whole call stack. So hide the JS call stack, and it just basically looks a bit cleaner. Now, because we've got this this error, if we get any other errors, we can check what kind of error we get. If we get one of the compiler errors, then we can hide the call stack and just basically do it inline. Otherwise, we can just show the whole call stack because it means something's gone badly wrong on our side and we need to fix it. So let's copy this for the parser. Parser error. Rename it parser error. And then we're doing the same thing again, toString. And then we'll also get one more for the evaluator. Okay, that looks fine. So now let's export all of these. Copy paste this. Oops. Cool. So that looks fine. Now if we go, let's actually put these errors in. So we've got our evaluator here. So yeah, you can see we're just throwing a new error. But if we import our new error, so sorry, I'm a bit ill at the moment. Evaluator error require should be errors like that. We can just throw new evaluator error, and then this will be our message. So do the same here. I think that's fine. That looks good for now. There's some more changes to this I want to do as well. Maybe we'll save that for the next episode. Maybe we'll do it now. We'll see. Parser, so we'll do the same again. I'm going to copy this import statement, and we'll do parse error. So here we go. So we can do, I think if we do throw new parser error, actually wait, I want to keep the string. So we'll do throw new parser error, like that. And then it should just return anyway. So I think that's alright, looks good. No more error cases in here yet, I don't think. Okay, fine. And then Lexa, let's do the same thing again. Import the error, Lex error. Yeah, so if we do throw new Lexa error, like that, then that'll be good. That's the only error so far. So now if we go back to main, we can use our try catch. So what we'll do, we'll create a new compiler object. So let, we'll do const compiler equals new compiler, and then we'll do, we'll just do console log compiler.compile, and is it input? What's it called? Yeah, it's just input. And then the error situation. So yeah, so like I said, we've got two cases of errors. We either have one of our compiler errors, or we have like an actual JavaScript error. Now let's do a little check. If error instance of, might need to import actually. Let's import this compiler error. Yeah, so if error is an instance of compiler error, then we'll just do console.error error to string. So that's our custom method we made, and I'll show you how this works in a minute. It's quite good. And then we just want to continue so we don't break out of the loop. And then otherwise, we're going to just console.error the console log the error, and we're going to break, because that means something's gone wrong. So let's add a comment. Hide the stack trace, and then this is unexpected error break. Okay, so it looks okay for now. Let's try. I don't know why I'm using PowerShell, man. I want one of these. Let's do. So 1 plus 2. That still works. So let's make this a bit bigger because I can't see. Right, let's throw an error. So if we do that, we get Lex error. What if we do 1 plus plus? So that's fine. What if we do? Let's just. I don't know. Maybe if we do AST, is that going to work? Okay, yeah. So we need to. So we've got the logic for this, but we haven't actually implemented like the printing logic. So let's add in optional debugging. If show AST, then we want to console.log. We're going to do JSON stringify. Now, yeah, this JSON stringify isn't not the prettiest looking thing. I will write another. If you remember back to like episode 1 and 2, we had the pretty print tree function. I'll rewrite that at some point, but it's being quite annoying. So yeah, so if this variable up here, show AST, is true, then it will print the AST. Else if is it show tokens? Yeah, so if show tokens is true, then we'll console.log compiler.tokens. I think that's fine. So let's try that out. So if we do AST, oh, that's not right. Oh yeah, okay, should probably change this. So AST, so you can toggle it on and off. So we get 1 plus 2, then it prints out our AST, which is good. It's a bit ugly, but it does work. If we do like a bigger nested thing, it will, you can see it's sort of indented in. Sorry about that. I think that's quite good for now. Let me also put this into its own file. So let's put that in compiler.js. Is it imported as well? Okay, sweet. So let's commit what we've done so far. Let's say tidy up, improve error handling, improved debugging. That looks fine. So now we're going to do the test suite. So let's make a new folder and call this tests, and then we'll start off with, let's do end-to-end test to start off with. So Node has quite a nice built-in, it's pretty good, it's like a built-in test module. So we're going to need to import a couple of things. I'm just going to copy paste these because I don't want to, yeah, they look correct. So yeah, it's this node :test and node :assert. It's pretty similar to every other like JavaScript test framework, like Jest, you know, Cypress, all those. In that you do describe to do a test suite, and then it is for an individual unit test, and then you use assert to check the results of functions. So let's start off with this end-to-end test suite. And when I say end-to-end, I mean basically we're going to initialize a new compiler, give it some input, and then we're going to assert that it's evaluated properly and we get some actual good results. So basically we're just going to test a load of mathematical operations and make sure we're getting the correct answer. So describe takes a string, which is just the name of the test suite, and then it takes a callback function, and then within these callback functions you can put your unit tests, and that's where you put it. We'll start off with should follow correct order of mathematical operations, and it takes a callback function as well. So let's import our compiler. Require src. Cool. So we'll do const compiler equals new compiler, pretty much exactly the same as we did before. So we'll start a new compiler, and what we'll do, let's start off with assert. Let's do strict equal. So we'll do compiler.compile 1 plus 2, and so a strict equal takes in basically the value you're testing, and then it takes in the expected value. So 1 plus 2 should equal 3. So let's test this out. So to run the test, you do node -- test, and you can see it has run, and you've seen our test suite, but we're failing. Oh, it's because it's a string. So we change it back to a number, and there we go. So we're passing. So yeah, so I appreciate this is probably not the most exciting thing in the world to watch. So I'm basically going to go away, write a few unit tests, and then come back in a second once I've done that. Okay, so I've got a couple more tests here, just testing the order of operations. So if we actually start our compiler, this is the wrong file. So 1 plus 2 obviously equals 3, 2 plus 3 minus 1 should equal 4, 4 times 5 divided by 2 is 10. 2 plus 3 times 4, that should equal 14. So yeah, so this sort of goes back to what we were doing, I think it was last episode, where we were adding the sort of priorities in parser. So yeah, it's this whole this thing. So yeah, so that's cool. This is good just to get us started for now. What I'm going to do now is I'm going to write some unit tests for the parser and the lexer as well. So sort of things like, basically I'm going to give it, initialize a new lexer and then pass it in a input string, and then we'll just compare it against what it should, like what it expects. And then just do that for some different cases. Also make sure that the error handling is correct. So I'm going to go away and do that real quick, and then I'll see you back in a second once I've done that. Okay, so added in some basic unit tests for the lexer and for the parser. So same sort of thing, just import everything, describe, and then it for each test case. So first one should tokenize single number. This is our input, and then this is what we're expecting. So it should just be a number token and then end of file token. So we create a new lexer, tokenize it, and then use a deep strict equal. I think use deep strict equal for comparing two objects or two arrays. Basically make sure that every element is equal. And then basically done the same thing for multiple numbers, so should tokenize that. Shouldn't pass float, so in the last episode we were getting that error where if you try and do like 1.2, the lexer would crash, and basically we fixed that now by implementing our new lexer error, so we check that it throws a lexer error when we call the function. So that's what it basically takes in a callback function and the error class it expects to throw. And then finally we add the operators, so just make sure that all of these get tokenized properly. So it does. And then for the parser, first test is pass a single number, so we pass in a list of tokens, and then we expect that the abstract syntax tree has this structure. Same again using the deep strict equal. And then we do a bit more of a, well, not complicated, we do a simple expression, 1 plus 2, and we expect the basically the different sides of the tree, different nodes of the tree to be equal to these. We make sure it's also a binary expression. And yeah, so if we do node -- test, you can see all of our tests here. So we've got the lexer suite, the parser suite, and the end-to-end suite, and they're all passing. So I think probably the final thing to do is actually, let's push this all up. We'll do add unit test for lexer and parser, as well as end-to-end test. And push that up. So this is our GitHub page here, so we can see we've just got this. If we want to add some CI, basically, some continuous integration, so we're going to use some GitHub actions. I'm just going to have a look how we're going to do this. So the first thing is it's going to be, we'll just write the name, so we'll do JS compile CI, that's fine. And we want this to trigger on every pull request. Yes, this, we'll just copy paste that from there, that's fine. And then the jobs, we're going to run basically run it on Ubuntu latest. I've got the GitHub documentation open in another window. And the steps are checkout code, and we just do uses action slash checkout v2. Don't know why that. I had a little squiggly line under it. Don't know why I had that. So then we'll also set up node v. I think we're using v18. Oh, I just opened OneNote, man. Node dash version. Yeah, version 18. Let me just close OneNote because that's annoying. So node 18. Oops. Uses action slash setup node v3. That's the version of the actual action we want to use with node version 80. Finally, want to run a unit test, and then we'll just do run node dash test. So that's like a console command. And that's main.yaml, that's fine. Let's just do create CI for JS compile. We'll just do CI, adding CI. I'm just going to force merge this because I can. Give it a second. But basically, now that we've done this, when we create our pull request for episode 4 unit test, it should trigger this CI. So let's just bypass protections. Delete that. So we've got GitHub workflows. So if we do compare and pull requests, so episode 4, tidy up code, improve error handling, debugging, improve debugging, add CI, add unit tests. That's good. So we'll create pull request. Now if we have a look, it's just queued up a workflow run. Let's see if we can see it. Nice. Oh, I run those tests so quickly. Amazing. So yeah, you can see it's got the little tick next to it. All checks are passed. We're just going to merge it. And there we go. So, in the next episode, I've improved the documentation a bit now. So if you are interested in this, then have a little look. In the next episode, we're going to have a look at variable assignments. So where you can type let a equals 5, and then you can reuse a further down the line and do some maths with it. And yeah, that might be quite a big episode. We'll also, in the next one, we'll also add brackets, so parentheses. So we'll create a new class, call it parenthesized expression, and basically we'll make sure that we handle any brackets before we calculate anything else, because if you remember back to bid mass, it's always brackets goes first and then the rest of it. So yeah. Alright, thank you very much for watching, and hopefully see you in the next one.